Hi everyone, welcome to our last lesson of our probability unit. This lesson is on Venn diagrams and mutually exclusive events. So what are mutually exclusive events? They are just basically events that cannot occur at the same time. So if event A occurs, then we know event B can't also occur. And mutually exclusive events are nice because there's a rule for their probabilities. So if A and B are mutually exclusive, then the probability of A or B is equal to the probability of A plus the probability of B. So that's really handy. If we know that the events are mutually exclusive, then we can just add up their probabilities, essentially. Okay, so Venn diagrams, these are a tool for breaking events that are not mutually exclusive, non-mutually exclusive events, down into events that are mutually exclusive, or mutually exclusive parts. So each individual section of the Venn diagram will be mutually exclusive with the others. So like here's a Venn diagram. Each of these sections are mutually exclusive. So we know that to find combinations of their probabilities, we can just add their probabilities together. And then, since these need to exhaust all the possibilities, when you add up all the probabilities, you should get 1 for like 100%. Okay, so let's look at kind of the parts of a Venn diagram. So here's a Venn diagram. This section here, where you're in the A circle but you're outside the B circle, this is the probability of only A. So like this area here, that's saying only A is happening. Okay, if you're in this area here, you're in the B circle but outside the A circle, that's saying that only B is happening. Sorry, my cat. Okay, if you're in the middle where they're overlapping, that's saying A and B are both happening. And then let's say you're outside all of the circles, that's saying neither A or B is happening. Okay, so that's kind of what the parts of the Venn diagram are telling us, and we can see that each of these sections is mutually exclusive, right? Mutually exclusive means they can't happen at the same time. So if we're in the yellow section, we can't have only A and only B happening, right? The yellow and the blue can't happen at the same time. They're mutually exclusive. We can't have only B and both A and B, right? Those are mutually exclusive. They can't happen at the same time. So the Venn diagram is breaking things down into mutually exclusive parts, and then we can use this idea that to find combinations of these events, we can just add up their probabilities. Okay, so let's see that. Let's say we want to know what is the probability of A altogether. So the probability of A is going to be the probability of only A or the probability of A and B, right? A happens here, it also happens here. So the probability of A is going to be 0.4 plus 0.1. And we know we can add them because they're mutually exclusive. So altogether, the probability that A happens is 0.5, or half. Okay, same idea for probability of B. B happens in this blue section, but it also happens in the green section. So to find the probability of B altogether, we're just going to add those sections together. So we're going to get 0.3 plus 0.1, which is 0.4. Okay, so that's the basic idea of a Venn diagram. To wrap up this lesson, we're going to look at one that's just a little bit more complicated. Okay, so we're going to use the Venn diagram to fill in the probabilities. So let's say we start with probability of A. So A happens anywhere in this circle. We have like only A and B, only A and C, and then only A, B, and C. So all of these sections are where A happens. They're all mutually exclusive, so we can add them up. So the probability of A would be 0.36 plus 0.02 plus 0.02 plus 0.10. And if we do that, we get 0.5. Okay, probability of B, that's anything in this circle. So we add up all of these sections, right? Only B, only A and B, only B and C, only A, B, and C. Those are all mutually exclusive situations where B happens. So we add them up to get the probability of B happening in general. So it would be 0.2 plus 0.2 plus 0.02 plus 0.02 plus 0.05 is 0.29. Okay, and then finally probability of C, it's the same idea. We're going to add up all the sections in the C circle. So 0.17 plus 0.10 plus 0.02 plus 0.05, and we get 0.34. Okay, now for the others, we're going to be looking at some subsections. So A and B. A and B both happens here. Let's highlight it actually. That happens here and it happens there. Those are both places where both A and B happens. This is only A and B, and then this would be A, B, and C. So this would be 0.02 plus 0.02, which is 0.04. Okay, B or C, so that could be anything in the green circle or anything in the blue circle. So we want to add up all of those sections, right? So that's going to be 0.02 plus, erase that, plus 0.02 plus 0.10 plus 0.17 plus 0.05 plus 0.2. So that looks to me like 0.56. I hope I'm doing the arithmetic right. Let me just check that. Okay, yep, 0.56. So I added up all of these sections because those are all sections where either B or C is happening. They don't have to both happen, it just has to be one of them. Okay. A and not C. So we need to be in the A circle but outside the C circle. So that could be here or it could be here. Those are both within A but outside of C. So that's 0.36 plus 0.02, so that's 0.38. Okay, oops. Okay, A and B and not C. So we need both A and B, so that would be these two sections, but we need not C to happen. C is happening here, so we have to take that out. So A and B and not C is only this section right here. So that's only 0.02. And then finally, A and B and C, that's all of them. So that's where all the circles intersect. So that's going to be the middle. So again, 0.02. Okay, so that's kind of it for Venn diagrams. The idea is to just kind of find the sections you need to add up on the Venn diagram and add them up because they're mutually exclusive to find your probability. All right, that's it.